Okay, what could possibly go wrong? The process of process change. So a little bit about SFEA. We serve all surface finishers in many different areas. We're not nonprofit, devoted to education and the diverse exchange of ideas. Ed Koenigsberg and I are involved in SFEA. Ed Koenigsberg is the media chair because he's the only person who seems to be able to operate Zoom without crying hysterically in the middle of things. And I'm the program chair. So I'm here to take your suggestions and maybe get one or more of you doing a program. We're generally very nice. We don't bite much. Next, please. Yeah. No, it isn't doing that. No, it isn't doing that either. There it is. So today is Veterans Day, and I'm dedicating this to my parents, and that's my dad coming home from World War II and my mom, and I'm the little baby in the center of the picture. Okay, we're critical cleaning consultants. I started the company in '94. Ed's been with me a long time, in the company too. And we provide process improvement. We don't do sales of product or we're just service consultants. We rent our brains. And we're involved in lots of different activities. I'm known as the cleaning lady because there's no better term for the field. And I'm a biochemist, clinical chemist, and for a long time involved in manufacturing processes. Ed is the rocket scientist because he really is one, and he's from MIT, so you can trust him. Yeah. We do have a lot of educational resources. We have an e-newsletter which comes to your in-basket approximately once a month. When I get around to writing it. If you haven't signed up, please do so. If you've changed your name, your gender, your email, whatever, and you no longer get the newsletter and want to get it again, let me know. We also do product quality cleaning workshops and webinars with Dr. Darren Williams at Sam Houston State University. And last but not least, we have herded cats because we're editors of the Handbook for Critical Cleaning.
We always say question authority, including us. This is our views because we learned from quite a few of our diverse clients that include manufacturers, providers of cleaning agents and equipment, academic institutions, military, and regulatory people. So we try to give you the best up-to-date information, but it's always best to check up. Things may change. Things do change.
Even during this program, they may change.
So, and you will be able to get a copy of this recording as well as the slides.
So we'll discuss a few dreaded words, some cost scenarios, a few more lurking costs, a little update on Environmental Protection Agency regulatory actions, and the process of process change. What are those dreaded words from the boss? We have to change the process. Take care of it in your spare time. And we've listed all kinds of reasons. I think that it is very likely that for technical, regulatory reasons, all economic reasons, people will be changing one or more of their manufacturing processes in the next few years. Next. So you know that our field is cleaning, surface prep, critical cleaning. So that's what we'll talk about.
The slant of this presentation has cleaning.
But the approach applies to pretty much whatever you're doing. But how hard could this be? Your boss may say, pick a cleaning agent, pick a new cleaning machine, and voila. Well, unfortunately, next. Things can go wrong.
So we have a few what we call ideal scenarios. And these are some of the things that involve the costs other than the equipment and the chemical. And we say ideal because we're saying that everything or almost everything goes right, or goes right the first time. These are estimates. They're not really case studies, but they are based on our experience, our observations in critical cleaning and surface prep. And as we've said, the principles that we talk about here apply to other processes as well, not just cleaning.
So, yeah, we came up with numbers for labor, for advisors, for travel. And then we also give some estimates for testing, verification, and approvals. And Paul, you know, being involved in medical and pharma, the testing can be more than half the issue, the battle, easily.
So these are some of the tasks that we feel need to be addressed when you're doing process change. They all cost money because they all take time, certainly. Not going to go through them in detail. You're going to have them
Don't have to keep,
in your package, but there's quite a few tasks.
Beyond going to trade shows and signing checks, it's for equipment. Okay.
So the first things on that list were set up a process team. A team is actually a good thing because an efficient team can save time, and that means money. That means that you get an efficient process much sooner. But your team has to have the right people so that you get all of the players that you need in the table. You need to begin with the end in mind. In the case of cleaning, is how clean is clean enough. And the important 2 C's, communicate and coordinate, always necessary.
So who should be on the team? Well, probably you're the chosen person, like the guest of honor at a luau, it's main course at dinner. But it's really very important also to get upper management involved because it makes them feel wanted and needed. And without the assemblers, technicians, operators, you are not going to get anywhere. And then we've listed a few other people, depending on your situation. But there's also the safety and environmental professionals. And if you're because they can really either make it very easy or very difficult. There's also the supply chain, contract manufacturers, and in fact, your customers. Sometimes we even get regulatory agencies involved, and those of you who've worked with us know that sometimes we actually get the regulators right in the same room with you. Next, please. Okay, so we have different kinds of cleaning, and this is ideal development scenario, general cleaning. And let's suppose someone's moving from a halogenated solvent to a water-based parts washer, or simply moving from an old aqueous parts washer to a new design. The primary cost is going to be maybe some performance testing. There's going to be relatively little process development or verification. We're going to assume no travel, no outside lab costs, and we're going to assume that you get it right the very first time. So you don't have to memorize this, but what you do have to say, these are all costs.
And these are estimates.
And they're estimates
of the amount of time, and then with our labor rates and such that we're providing, how much that would actually wind up being.
You spend a little time with some meetings, maybe with some advisors, that kind of, not with advisors, but maybe with your customers. And we estimated 37 grand. Whether you might buy a $20,000 parts washer, but we're estimating 37 grand.
Yeah, extra, beyond the equipment.
Right, beyond the equipment.
And now the second one is also with a general cleaning application, but switching from a halogenated solvent to a non-aqueous process. And we're assuming that we're going to be using a flammable solvent for this.
Because a lot of halogenated solvents are under the gun and may be heavily restricted and or banned.
And a lot
which
of
is
the
a kind of pretty
replacements
much a-
are flammable.
So there's more labor and advisory costs because we figure you're going to have to take more time to learn about the cleaning equipment and process options. We're figuring medium costs for process development and verification. No travel, no outside lab costs. This is real optimistic. Again, this is home and garden television. You solve it in a short time. The property brothers come in and fix up your house in shades of gray, black with bright colors, and it's gorgeous. But again, here are the costs without equipment and chemicals.
And now we're up to we're at 86,000 because it's a more complex project, and there are a lot of different things that you have to consider when you're dealing with a new solvent or flammables.
And that's in addition to buying, say, a small flammable solvent degreaser, which starts at a couple $100,000 and then moves up. And it allows things for like fine tuning the equipment and training the employees because it's different. It's a different process. So then we get into what we'll call high precision. Again, moving from a halogenated solvent to low flash point, but you've got lots more regulatory and permitting issues. Maybe you've got NADCAP involved. The manufacturer, we're assuming that the manufacturer understands the process is not just downstream, but upstream. So you know what your suppliers are doing. That is not an automatically good assumption. We also have to assume that you as the manufacturer understand how clean is clean enough. Sometimes you know it's clean enough, you're not sure why. And then sometimes we're assuming that we have to assume that the customer has specific cleanliness expectations and communicates those expectations clearly, intelligently, and rationally. Again, we're in Disneyland, but next, please. So again, we've moved up to 95 to nearly 96 grand, and we're getting into some auditing the suppliers, talking to suppliers more and more, trade shows, that kind of thing. You can say you're all wet on this, Koenigsberg, but this is based on things that we've come up with, and it's pretty optimistic.
Yeah.
And these are also things that people don't really track because different
Right.
parts of the company are involved.
But everybody thinks, oh, we have to be worried about the cost of the equipment. We have to be worried about the cost of the chemicals. These are not in these charts.
This is the worrying about the cost of not messing around and doing it right the first time. Now, scenario 4 is safety critical cleaning, things like medical devices, where some military, some advanced automotive, aeronautics. Safety critical means people's tushes fall. Yeah, it's got to work. People's tushes fall off if it doesn't work. And we're assuming that they're moving to a new low flash point solvent because, again, a lot of the halogenated solvents are under the regulatory gun. And there's a significant effort for preliminary performance testing and cleaning validation. And again, cleaning and equipment costs, cleaning agent and cleaning equipment costs are excluded. Next, please. So we've made some really hilarious assumptions here. Everything's right the first time. The final fabricator and key suppliers work seamlessly and harmoniously. There are no false starts. There are no mistakes. People say, I'm going to choose this piece of equipment, this cleaning agent. They get it right the first time. Management doesn't get squirrely or change its mind. And if it's medical, the FDA is deliriously happy and has no comments, no reservations, and wants no changes. So this comes out to more like, we're assuming we're at an implant
close to 300,000.
And if you have 2 different medical devices, you got to double the you got to repeat the evaluation.
In red, there's some additional tasks here because of the validation and testing and addressing any concerns from the control agency, whether it be FDA or
Yeah,
the military, whatever, who's involved.
yes.
So there are very significant costs at that level.
So we're being very optimistic. So this is when everything goes right. Again, highly idealized and optimistic. The costs can, even for well-planned projects, can be much higher. And we've been looking into this a lot for various reasons, to the point of asking people who in say testing labs, how much do all these tests add up to? How much time do you spend on the phone? How much does the advisory time costs? So everything costs money. Arguing costs money, and not understanding cleanliness requirements or production expectations or limitation, that's all costs money. So for general cleaning, 37 grand for from going to a new aqueous system, going to a flammable system from say halogenated, 86 grand. Then it goes up to 95 grand for high precision. And when you get into the really heavy duty safety critical category, upwards of 275 grand. Usually conditions are not ideal.
Right. So these are all what happens when it goes right. But what can go wrong, especially if we take
Absolutely
some
nothing.
shortcuts?
Nothing.
And that's what main topic of this.
So this is my
presentation is.
favorite. This is what's gonna get the grandkids through postgraduate school. The company president said, I just played golf with the vice president of marketing at Whammo Clean. And he says Whammo Clean XL equipment costs $250,000 less than what you were thinking about. And the rep guarantees it will clean all of the soils. And the rep says that in the last 12 months, there have been 200 new Whammo Clean XL installations across the US, and they all work perfectly.
So
The boss says,
don't bother with a cleaning team.
yeah,
And we're advisors. We can do it all. Don't worry about that regulatory stuff. We know what the customer needs, so don't spend time there. We know we're going to get the Whammo clean, so don't bother.
don't competitive bid. What
bother with the bidding, and we don't have to bother with testing.
Because the rep said it always works 200 times, never a failure. So
we started with this. This was our ideal situation without
96
without
grand.
these shortcuts, and
the boss
yes, it's
said,
sizable. 96,000 bucks is not peanuts, but and so what happens when you apply these shortcuts? Wow, you can go down 80%, down to 21,000.
real cheap.
By cutting out a lot of those steps. And so that's what happens if
it works. If it works.
And they might, but much more likely when you start doing your shortcuts, they backfire. And it means you're gonna have to start over, taking more time, more money. You're gonna have lost business. You may need to make some last minute emergency decisions, which always cost a lot more than you planned and still may not be ideal. So you're winding up spending a lot more time and a lot more money. So the bottom line here is with the so-called ideal scenario, maybe 96,000, you might have been able to go down considerably below that, but recovering from those shortcuts can really sock it to you at over 200,000. So you wind up, instead of saving 80%, you're spending more than twice as much.
And frankly, we've seen things that cost even more than that. People wander in circles again and again.
And you're wasting valuable time and your own reputation, which is not part of this.
So
scenario.
here's the infamous Excel spreadsheet, and That's the third development scenario of
So,
it.
so it
but-
costs a lot more time and money, plus you still have to add in the cost that you did to try those shortcuts, which didn't work.
So this is, we're actually done, I think, with the god awful Excel spreadsheets.
Yes, we are.
Apologies for those, but this is something that's come to our attention, and we didn't, it's nothing that we have done, but there was a study of a metal finisher that was attempting to replace solvent degreasing. They had mixed substrates: stainless steel, carbon steel, copper, brass, assorted aluminum alloys, we think. They do anodizing, plating, powder coating. They cover general industrial, automotive, and medical, real eclectic. The pinch point is that they've got a lot of heavy oils and polishing compounds, and currently they degrease in N-propyl bromide. We'll tell you a little bit more about that later, but that is under heavy regulatory scrutiny by the EPA. So the way the story, the way it was recounted, they did a little bit of testing of highly alkaline aqueous cleaner, because they had real heavy lubes and polishing compounds with a grit in it. So a cleaning agent supplier tested this thing that was like pH 12, 13, something like that, mild, not really. And it took the stuff off. I don't know if they tested for materials compatibility or not, but just the dirt went away. They rejected a relatively sophisticated equipment because of the cost: immersion, agitation, ultrasonics, multiple rinse, I think no dry. Very limited testing by the equipment supplier. They shortcut by selecting a single tank ultrasonic system with immersion and ultrasonics, no rinse, no dry, and they thought about adopting it without any testing. Then we get into rinsing, and there are a lot of water folks around here. So they thought about shortcuts. They went from an industrial immersion tank with ultrasonics and no rinse, and they were going to hose it down with hot tap water. Then, which is so much fun with aluminum. Then they considered also continuing by rinsing that high pH aqueous degreaser using the existing rinse tanks in an existing plating lot. And they were going to use tap water at all steps because the water quality was judged excellent. So the bargain process was thought about, but hasn't been tested or adopted. What might go wrong? Well, as soon as you get into degreasing mixed metals in aqueous, it gets a little more challenging. You got to be more careful. You can have materials compatibility problems with different cleaning agents. You can have galvanic effects from the product mix. Aluminum is a royal pain, and alloys behave differently. And Mike Valente did a webinar not too long ago about water-based cleaning of aluminum alloys, and let me know and we'll get you information about that one. It's generally ill-advised to use rinse tanks for more than one purpose, because all of the mixed soils in the rinse tank can make a god-awful mess. Cleaning agents, polishing compounds, lubricants, stuff for plating versus stuff for degreasing. Plus, most people feel that processed water ought to be defined and controlled. Tap water can be variable, and sometimes
Variable both by location and season.
Definitely. And we can talk about the purple coffin corners that occurred because of agricultural runoff. All of a sudden, I got a frantic call because of the tap water that had been good. Next. Why are shortcuts bad for business? Why don't we have to bother with a cleaning team or advisors?
Well, you wind up with poor, uncoordinated decisions.
We don't have to bother about regulatory stuff.
You wind up being shut down having process delays, fines, and we've even
In prison, yeah,
found some cases
yeah.
it gets beyond that.
And at the very least, your in-house safety folks can stop you from adopting the process, saying, we don't like this.
So we don't worry about talking to the customer. We know what they need.
It's always good to communicate stuff like this to the customer because they can get irate, you can lose their business, and the competition wins.
What happens when you don't competitively bid?
You can get really dreadful process equipment. You might pay too much. You might get the wrong equipment for the job. You can sometimes get poor product support for the equipment. So when things need fixing, it can be a problem.
And when we say competitive bid, we're not just talking about the price.
No,
we're talking,
no.
We're talking about evaluating what does it do? Does it do the job? Does
That's a good point.
Does it do the job well? And is there customer support from the vendor of that equipment?
You don't have to bother with cleaning tests. Just trust everybody, right?
Right. Well, we know what happens.
Yeah.
So there's a few other things that we want to talk about in terms of lurking cost.
What is the secret to bargain equipment?
Bargain cleaning.
Purchase quality equipment. Budget for peripherals, filtration, recycling, closed loop fixtures, the right amount of rinsing, the right amount of drying. Effective cleaning is not cheap. Sizing is important, and you have to figure the total parts per day, but also bumps in the production schedule. You don't want to have bottlenecks. Sometimes equipment manufacturers will bid something a little smaller to avoid sticker shock. And go read the fine print, figure out what's going on. You know, in other words, ask for help with sizing the equipment, check the math, assume some wiggle room. Size the equipment with some room for growth.
Size the equipment, will it actually dimensionally fit? We've had
Yes.
We've had situations where, oops, it doesn't fit through the door, or
the hoist hits the ceiling.
It's taller than the ceiling. So all of a sudden you're wound up with a new facility bill.
Next. So don't cut corners. That doesn't mean you get every bell and whistle. Really, it doesn't. It doesn't mean you just buy everything. It's not like, you know, buying a sports car. But get it in writing, including the performance, the delivery time, the installation, the training, the product support, and if they don't deliver, don't pay. So here's a few examples. One large aerospace company didn't use a supplier with a PERTINENT experience. It was a good supplier, but he was not experienced with that kind of equipment design. They poured 300 grand into a bottomless pit beyond the cost of the equipment. They couldn't get it to work. The supplier says, don't worry. The requirements and product support were not adequately specified in writing. The equipment leaked. The parts manufacturer had to do the troubleshooting. Plasma Technology, who we can talk about because they've published with us, had the manufacturer guarantee performance in writing. Was the initial build absolutely optimal? Because it was custom equipment. But PTI had the ammunition to get the equipment fixed, and it's been running great for a couple of decades now. Next. Why is that not? Okay. One of the things about manufacturing is you look at your own facility, but you don't look at what happens upstream, what happened before. So you really have, and you may not look necessarily at everything that the customer needs. So the cleaning process has to be collaborative. Specifying the cleaning in the contract is important. Auditing may be necessary. We've had situations where purchasers had the brilliant idea of going with cheap generic suppliers. And then they wonder why the costs are going up because the quality isn't there. If you're in the supply chain, become the solution, not the problem. And that may be involving tactfully educating your customers as to why you're doing what you're doing.
So you want to partner with your suppliers. Select them intelligently, collaborate with them, because you can't always audit them, partly because of secrecy effects and intellectual property. They know what they're doing, but they don't necessarily have to tell you exactly every part of it. But you must get them to at least agree that if they do something that they don't tell you all of the details, get it cast in concrete so that if they make any changes, they let you know.
So you have a chance to look at what the change is. Because you may be changing a process that you don't know. Now,
So
little update to the Environmental Protection Agency. What is TSCA? It's something that it's Toxic Substances Control Act, and TSCA may result in trauma, but it is not an opera. Now, this is for those of you folks who are out of state or who think you can leave California and avoid this. What we're talking about right now is it affects the entire US. So it's not just California. It has sweeping authority over environmental and worker safety, just like OSHA does. So this is called TSCA reform or amended TSCA or Lautenberg would be the terms you'll find it under. Next. So remember I mentioned halogenated solvents. Well, N-propyl bromide, methylene chloride, perchloroethylene, and trichloroethylene are set to be highly, highly, highly regulated relatively soon. And that's based on bipartisan congressional mandate. And I do mean bipartisan, yeah, it happened not too long ago. Could be banned.
So they've done a final risk evaluation on all four of these that was completed last year, 2020. And so they're now in the risk mitigation phase of figuring out what they're going to do about it. Now, why are we concerned with it? Well, for one thing, their actions can impact our clients in the manufacturing community because we deal with cleaning agents, cleaning equipment.
Costs, evaluation.
But also,
before we go beyond that, chlorinated solvents do stuff that other solvents don't. They clean real good. So a lot of the parts that you find it easy to plate or anodize are easy to plate and anodize because somebody used a strong solvent that gets into all the little nooks and crannies. And it's kind of like life is getting a little too exciting on this.
Yeah.
The other thing is we're a subcontractor to the EPA. We provide technical information about risk management, about flashpoint, about solubility, and we've been involved in evaluating the risks and benefits of alternative chemicals and processes and the costs. We are not involved in the tox risk assessment, nor are we the EPA.
Right.
We don't run it, so don't blame me, please.
But what can they do, and what are the timelines? Well, they can ban the manufacture, sale, or use. We're not sure yet what's going to happen, but one of the possible scenarios is that they will wind up saying, well, of those four chemicals, methylene chloride, N-propyl bromide, trichloroethylene, and perchloroethylene, only the PCE will be allowed, and then only if you're using it in an airless cleaning system, which means an expensive piece of equipment.
It means it's very non-emissive. You lose practically nothing, and nobody. It's not there. It's like a roach motel of solvents. Yeah. So it looks like the rules will be in by the end of 23. there probably will be a timeline, probably not a sudden cutoff. And what's left? Well, there's something called trans DCE, and that's blended into the fancier designer solvents to make them work without catching fire. But trans DCE is very similar in structure to the stuff the EPA is regulating, and the EPA is looking at trans DCE. So what will be left? Darn little. And already we've gotten a few phone calls of people who are using trichloroethylene, and one of the manufacturers in the US, seeing the writing on the wall, is no longer making the stuff, and all of a sudden it's like, help.
People are still using it.
People are still using it, but they don't know
where it's still legal to use it.
And it's still legal, and they don't know what they're going to do. So they have a last minute process change, and they've got to scramble. So under what can go wrong, that's a biggie.
Well, so as I think we talked about earlier,
We gotta-
some of the scenarios involved moving to a flammable solvent as your cleaning agent. And again, some of the reasons why they might do that is because of either national policy, including EPA, or local, or even corporate and customer policy.
And sometimes
Some of the customers say, corporations say, we're not going to use these, even if it's legal to.
And sometimes flammable solvents are the correct technical choice. Some manufacturers may move to acetone because it's not a VOC. There is a flammability issue. Usually the costs go up, usually. Sometimes there are costly facilities changes required, which we didn't include in the other analyses, or insurance may not be available. One coder was actually able to get insurance for a cleaning process by using acetone in a 55-gallon drum, and they would just pull it off, followed by high temperature metallizing. What could go wrong? Our stance is, don't do stuff like that. It's not a good idea. Next, please. Insurance. Yes, we've actually looked into insurance as part of this project, and that's been a magical mystery tour. We've looked at a lot of, we've spoken with folks in E&O and liability insurance, and a really good trial attorney. Well, one thing about flammable versus a carcinogen, problems with flammable solvents have an immediate dramatic effect. The injury and death impresses jurors, and that can be immediate and have long-term consequences. Right. So insurance is likely to increase. How much? I don't know. Next.
We don't know.
Nobody knows, or nobody will tell us. So in conclusion, honest, we're getting close to the end.
Yes.
How to change the process without breaking the back. Coordinate, communicate. So back when we were remodeling our house, we made a trip to a marble yard. This was back in 2002, and it was a major remodel. And me being me and liking to coordinate things, I brought little samples of tile and wood and hardware, because it's easier to move little bits of tile and wood than hardware than it is to big slabs of marble and granite. So this guy, who I think was an engineer, I think so, because his socks didn't match, because he came really agitated, and he said, "You've got to hide. I can't, go away. My wife can't see you." Because I told her we're going to pick the tile, then the wood, then the hardware, and she's going to want to coordinate. Yep, he's an engineer. And then his wife saw me with the samples. And she was wearing this gorgeous saffron sari, and she grabbed him by the ear and said, "Come, dear, we must coordinate." And she's right. For successful process change, you've got to coordinate. Can coordinate manufacturing, assembly, the cost, the quality, the safety, the environmental. Next. Also means communicating. One of the things that costs people a heck of a lot of money is look at the information, but understand it, process it, and communicate. The information is not enough. You've got to communicate in simple, short sentences. You know, like a noun, a verb, a little punctuation, maybe a few adjectives and adverbs. The Food and Drug Administration loves full sentences when you're trying to say something to them. It shortens your process development time tremendously. Next, please. Also plan for the unexpected. That means having a good, educated cleaning team with strong management background, the right people at the table, including the techs, including the right advisors. You have to have a good education and understanding of your options, what you need for your application, a process selection plan, a process validation plan, and maybe a backup plan or two. And I always get a little itchy when suppliers say, don't worry, send us the sample, we'll take care of everything. When that happens, you got to say worry.
So
we're to the ever popular question and answer period. And let's see, can we get back to
the,
yeah.
Good, and the recording light is still on, so hopefully we'll.
So
have
are
this
there
for
any,
everybody.
are there any questions? No one? Nope.
I have a question for you.
Okay.
So you referenced the MPB and the other TASCA related
Yeah.
solutions or chemicals. Do you have an estimation at this time as to when they may be banned or phased out, I should say? We're starting to look at that.
No, I think it'll be, I think it's likely to be sooner rather than later. So we run into two extremes. People who would like you to buy some other cleaning juice and buy a new cleaning machine say, oh, it's going to go away right away. It's going to be banned. You're going to get in prison, do something right away. Switch, you know, again, it usually is accompanied by, I've got the solution, switch to it and nothing, you know, it's going to be right away. A few, and I don't think it's going to be an immediate cliff. I do at the same time take issue with people who say, oh, the EPA takes its time. They can take decades. That is true to a point. This particular legislative thing, rule, law, whatever it is, everybody on the right and the left seems to like it. So please don't say I should have voted for who I didn't vote for, because everybody seems to like it. And so saying that you're going to have a couple of decades, I don't think so. They're pretty much lit a fire under the EPA. And because it impacts both environmental and worker exposure, it takes us straight into OSHA land. Does that kind of answer the question with an I don't know, but sooner rather than later?
I think we sort of indicated that it looks like the indications are the first rules will be out by next summer, but then they have a year in which to get comments and amend them before they actually go into effect. So we're talking about maybe the summer of 23.
Those aren't the, there was,
But again,
yeah, and there was an immediate list of 10,
Mhm.
and N-methylpyrrolidine, NMP, N-methylpyrrolidone, and Pyrrol was on that list. And then trans 1,2-DCE is on the next list. And those are all being relatively fast tracked. So, and this is kind of a never ending thing. I mean, they could come up with a list 3, a list 4, a list 28.
and we don't know what changes might occur when they start, if they start saying the energy that you use is more important. And so we
Although we
because
haven't,
of-
you know,
because of global
you,
warming effects.
you've
and-
said that, but I don't think
But we
so.
haven't heard anything
We
about
haven't
that
heard
yet,
anything about
but
that.
it could happen.
And it depends on who does the analysis.
Or some of
Yes.
the replacement solvents contain fluorine and carbon. Well, that can break down to your PFAS.
So-
And that's gotten a lot of attention recently and will continue to. So,
That's
Um,
actually a different program that I didn't want
right,
to get
it's other
because
parts of the EPA. So,
when we do that part of the program, the whole bottle of wine is going to be on the table,
Yeah.
I think.
right,
But I really wanted to get involved with discuss the technical aspects of it, because whatever happens, for whatever reason, if you handle the process smart, if you have your ducks in a row, if you're working with your safety environmental folks, they're going to tell you what's coming down the pike. If you talk with your suppliers, they're going to say to you, you're using water, I'm using solvent. For medical devices, Paul, you know, the final assembly is done in clean rooms in temples where they worship 70% isopropyl alcohol and Wi-Fi water, which is water for injection. You know, it's kind of, but that doesn't mean that things didn't happen up the supply chain, because we're talking the final assembly. So the point is to, whatever happens, how can we be kind of smart about this? How can we be intelligent? Because maybe you got to change your processes for technical reasons. Maybe you've got a new product line in. I know as soon as I say regulator, it's regulatory, it kind of
yeah.
takes over everything. Anybody else? Anybody want to fight with me? With Ed? Take
I just
issue.
had one comment for a lot of
Sure.
our processes and cleaning. I kind of agree that you need to obviously assemble the right team, but as an engineer, sometimes we like to just stick with other engineers. So in the beginning of the process, sometimes it helps to get like outside and like fresh perspectives. So like just bringing someone from maybe finance or HR
Oh,
or a different team who actually
sure.
who doesn't maybe have an idea of what you're trying to achieve. So it just helps to kind of get a new, fresh perspective and take on the room.
Yeah,
So
that's
I
and,
think-
and it can be a really good idea to get purchasing in there, because if they understand your technical goals, they can help you to find the right solutions. If not, they may say, oh, let's just use the cheapest.
Right. I think, and it's also helpful to sometimes have people on your team or the people that you're talking to who don't really understand the lingo. Because now you really have to explain what it is you're doing, how it works,
That's a great
and
point.
why you're trying to do it. And other people who have been enmeshed in this for decades have a whole different vocabulary.
For sure. Absolutely, for sure. Oh, and you might want to hire expert consultants like BFK. No,
No.
you could. Actually, we've sat in on some team meetings, and sometimes I have no background in psychology, but sometimes it's very helpful to just have somebody in there to kind of.
I agree with what the gentleman said on getting somebody else in the meetings, because years ago, we were doing some very critical work with semiconductors back in the 70s. And the purchasing manager, we were using transistor grade acids, and he got a better price, and he went to
Yeah.
reagent
The
grade.
agent gate, yeah.
Yeah.
Been down that road.
He does not understand what we're doing.
Right.
Yeah.
So it's real pragmatic. We have actually gotten South Coast Air Quality Management District on some team meetings. SCA QMG, we have lived to tell about it. It has been extremely successful. They don't bite much, especially if you get them involved. They feel wanted, loved, and needed.